You guys can see from remote, right? Assuming you can. If you can't, just chat and let us know. Thanks, Victron. So it's a lab rotation course for our PhD students. Now, our PhD students, when they first come in, they are not assigned an advisor. Okay, so that means they have a semester to rotate courses and find which lab they want to rotate in. You will see some of our PhD students in week 3 onwards. Okay, so they come in week 3. The first half of the semester till week 7 after recess week. First bunch will be with us, and then the second half, week 8 to week 13, they'll be with us. Now, some of us as undergraduates, or even we've had NUS high school students come in and they're like, well, I can't compete with a PhD student. I mean, there are people from industry here that are much older than I. How can I compete? And the answer is, it really doesn't matter. Okay, because the whole point is that you come in knowing a certain level about RAG, and you go out hopefully much supercharged with that. Okay, I'm not expecting everyone to get the math. In fact, the math is the least concerning part. Okay, it's more of the importance of being able to understand, network with other people who are like-minded, interested in RAG, interested in LLMs, interested to get something on your resume that will land you a nice internship or job. All of those are good things, right? And because we have a very large spectrum of people, from high school students to professionals, there is a network right here in this room that we will build up as well as on Zoom that can help you build a community. And that's why we have a Slack workspace to support. Okay, so that tells you why we have a lab rotation. Okay. So this is why we have this. Now, many of us are undergraduates. How many can I show of hands in the room? So we've got 6 undergraduates online. Are there any undergraduates? So if you're an undergrad, you can just give a thumbs up. Okay, so we have 2, 3, 4, 5, 6, 7, 8, 8, 9, 10, 11, 12 of us or so. Okay, so another of these folks will be doing the course for modular credit. Okay, units, as it's called, 2 or 4 units. 2 units, as you may know, is 70 hours of work. The normal 4-unit load is 140 hours, which means roughly 10 hours a week. Okay, so you have to decide how much credits you want to work for, and I'll be going through how that works. Okay, it's also a reading group for my team. So I lead a research team of about 15 students or so, undergraduates, masters, graduate students, postdocs. These 3 of them are in the room, so you can raise your hands. There's Yisung in the back, Jai next to him, and Jechang on the right here. And there'll be a couple others coming in next week. Some of them are not back because it's week 0. Okay, and it's also an audition task for guest learning looking to join WING. So you heard online there are a couple of people who are thinking of joining the lab as PhDs or postdocs. They're also in this because this is the way that I audition students. Okay, Chen Hao, you raised your hand. Do you want to unmute and tell us your question? Did you have a question? Okay, if you have a question, just go and unmute. Otherwise, I'll go ahead. Okay, and then finally, like it says here, it's an open to the public external course. So if you have friends that want to learn about RAG, you can tell them to go to the YouTube, or you can tell them to just join the Zoom screen. Okay, you can ask B to give them an invite to the Slack workspace. It is an individualized link, so you need to let me know. Okay, everyone clear about that so far? Okay. Going to go to the next slide. All right. So how it works is really simple. There are going to be a couple different responsibilities. All right. Because I'm not actually teaching this course. I'm scaffolding this course for you guys to teach each other. If you find that daunting, it is a little bit, because many of us haven't done public presentations where you stand in front of the classroom to do that, right? Okay, but I guarantee you, you will get a lot out of it if you're able to overcome your fear of public presentation. Okay, and because we're doing it in groups, it will be okay. All right, so what you have to do, everyone, including external guests, have to do the following, right? So it says here, you have to do one of the following, all of the following, sorry. Do a lecture, okay, where you work with a team on this, okay? You have to also support a lecture, okay, not one that you're doing. So if you, let's say, lecture in week 3, then you can support on week 4, okay? And you have to attend all 13 lectures because it's no fun if you're lecturing and there's nobody, right? Okay, and you have to participate. So that's going to add up to roughly 50 hours or so. All good so far? Okay. The other thing really important is you have to do a group project. Okay. I suggest you actually do it in a group, meaning not a single. Okay, but I understand some people are like, oh, I have external work commitment. It's not easy for me to coordinate with people. You know, the NUS students are all in the same place. It's easy for them. It's okay if you have to do an individual project. Okay, but it's much, much better if you work with a friend or strangers because it opens your network. So this is a very key part of building a community. Okay, so I'll tell you how to do that later. Okay, so that will total up 70 hours. So you get your 2 course credits if you're doing undergraduate CP3108A. Okay, or if you are listening to this in a couple weeks' time and you're a PhD student, you're doing a lab rotation for either the first half or second half of the semester. Okay, the second way is to do it for an additional 70 hours, right? And so what do you have to do? You have to prepare an additional lecture and support an additional lecture. Okay, so that means 2 lectures, one in the first half, that means weeks 1 through 7, and then one in the second half, which is weeks 8 through 13. Okay, so you do a little bit of both, and you have to do a more detailed group project and more detailed preparation. Okay, we have to negotiate that. Okay, now if you're an external member, you will know there's no way as an NUS lecturer I can compel you to satisfy all these requirements. Okay, but you are here hopefully on good faith, okay, that you want to do the course. Okay, so that means we need some type of agreement from you, gentlemen's or ladies' agreement, that you will actually do all the things that we ask. Okay, if you cannot, let me know ahead of time. So I have a work commitment, I have to deliver a project on a certain day, I can't do it, then I need somebody else to take over. Okay, don't tell us last minute because let's say we have lecturing duties and we decide you know, Wednesday night you're not available, then we're sort of stuck, right? Okay. So you may be wondering how to do this. So I'm going to share with you how that works. Okay. People who remember 6101 from last time will understand. So let's see how to draw it from. So in our Slack workspace, okay, and you can open up your computer if you have one. You will see the bookmarks, right? So the bookmarks here have a sheet. Okay, this is the Zoom link that we're using right now. So you can go to the sheet. Okay, so everyone go and open the sheet. Okay, I will show you how to use the sheet. Okay, so what you need to do is pick a row, pick any row. Okay, it should be editable. Okay, and then you can fill it out. So I'm just going to go ahead and do the same as I've already done. Okay, write my name down. Okay, I'm going to select my affiliation. Okay, so I'm a member of WING. Min has unfortunately forced us to do this reading group. Okay, and I'll save the team ID later. I can put down my Slack ID if I remember what it is. Okay, if I'm an NUS student, you can write this down. Okay, NUS net. Okay, and then I'm asking you to fill out your preferences. Okay, so as a lecturer, that everyone has. Okay, you can choose one of all the lectures that you want to help. Okay, so week 0 is now. Week 1, you guys are not responsible. It's myself and you lectures. But from week 2 all the way to week 13, you can have bunches of people, both remote and in the classroom, giving the lecture. Okay, this is why I wrote this classroom, because as you heard earlier, it's actually quite audible. You can hear everyone from remote. Okay, so we can actually juggle this as a hybrid learning scenario. Okay, so I think that'll be quite an interesting challenge. Okay, so you need to select one. Okay, and you also need to select a support week. Okay, so check with your schedule. You know, for example, if you're an NUS undergraduate, you want to avoid like week 7 because everyone knows we all die during midterms week. Okay, then probably you also want to avoid week 13. But the topics are listed there roughly. You can choose the topic that you want to do, okay, and choose what you want to support. Now, of course, you're wondering, okay, man, that's great, but how come? What happens if everyone chooses the same lectures? That's going to be a problem, right? Okay, so there is a mitigating factor, and it is me. I have veto power. Okay, so if you scroll a little bit, sorry, to the right, there's all this blue stuff. Okay, the blue stuff you cannot touch. Okay, I can touch. Okay, so I will tell you where I'm bordering you. Okay, so let's say, for example, you choose, let's say, this gentleman here. Bangmei has chose multimodal RAG, and I find there are too many people with multimodal RAG. I will assign that person to another lecture. Okay, so the idea is I want a uniform distribution, but I realize not everyone will have a uniform pace. Okay, so I can force certain people to take a different lecture. Okay, everyone clear about that? So we want an even distribution of lecturers and support staff that can help them with lecture. Okay. So when you do the lecture, you will have to fill out also this information, like which segment of the lecture did you do? So usually there's like 3 lecturers. So each person takes about 20 minutes to give a paper or 2. Okay, you just select which lecture you did. So maybe I did today I'm doing lecture segment 1. I'll type that in. And when you do the supporting role, you have to tell us which type of supporting role that you do. Okay, and I will go over these supporting roles in a couple of minutes time. Okay, there's this a quiz setter. Right now we have somebody called a scribe and scribe finalizer. I'm thinking I will discuss with you what these things mean and whether they make sense. There's another person to do the web page configuration to take into account all the materials that you create. Okay, then a coordinator who coordinates the support team, and a discussion catalyst whose job it is to pepper the audience with questions. Okay, because it's no fun if it's just lecture. We are here as a reading group, and that means we want it to be interactive. Because we learn better that way. If you have a lecturer standing up here, you can watch it on YouTube. Why come to the lecture, right? So, you know, we want to discuss. Okay, so these things will come into play later. You also will do the self-assessment, okay, in column Z for all the credit taking. Okay, so you can say how many hours you worked on lecture, how many hours you spent supporting, and then the work that you did for weeks 0 through 4 on your project, all the way until week 13, and some miscellaneous hours. Okay, this is sort of my audit of the time that you spend on the project. If you make hours that are like really ludicrous, then I'll catch you. But otherwise, we'll just let it go. Okay, because I think people who are taking this for freeform UE credit, they are here for a reason, right? We're not trying to cheat ourselves out. Okay, so if you're an external guest, you don't have to fill this out, but it's helpful if you can. Okay, just to help out. Okay, the other thing that we will be doing is setting teams. Okay, so in the projects channel, okay, you can start to think about what type of RAG project you want to do. Could be related to your work. It could be related to your research. It could be related to replicating a paper that you saw online or that already has GitHub code. Right? Maybe all you need to do is fork the repo, run it on a GPU, and then you're done with the project. Okay, not quite, but you would start with that. Okay, so the important thing is the project gives you hands-on experience with RAG. so you can put it on your CV and resume. And as you probably know, it is a skill that's highly sought right now. Okay. Do you have any questions so far? Anyone online have a question? Okay, so the projects channel here is meant for you guys to coordinate what you want to do. Okay, so for example, when you're preparing your course material or you're looking on ahead at certain things like your particular topic, for example, let's say Chen Yang is doing maybe vector stores, okay, as support. Maybe he can take a look at vector store papers and then pose a project about comparing different vector stores. Okay, then he could write a message on projects saying, hey guys, I'm interested to do a vector stores project. Do any of you want to join on that? And then you can reply to the thread. Okay. And what we'll do is we'll manufacture team IDs for you guys so that you can. Okay. Everyone clear about that so far? So the projects channel is mostly for you to self-organize into project groups. If you already have a buddy, that's great. Still put your information into the projects channel so I can capture it later. Okay. And if you need an identifier, like say, okay, me and buddy X are going to do a project together. We don't want anyone else to participate because we're going to be doing the coordination on our own. Okay, can you assign us a group ID? Okay, then I'll put that here. Then you can propagate it into the worksheet. Okay. Everyone okay with that so far? Any questions? Okay. Any questions online? You guys are free to interrupt anytime. Okay. So let me go over the.
I have one question.
Yeah, go ahead.
I wanted that what's the GPU resource we can use?
Okay, if you're an NUS student, there are certain GPU resources available to you. If you're an external guest, unfortunately, we cannot make those resources available to you because that actually costs money. Okay, so if you have access to GPU resources, you can use those on your own to complete the project. Otherwise, you can try scoping down your project to something that you can comfortably handle with the computing resources that you have. Okay. There are plenty of LLMs that can now run on commodity laptops. You don't need to have such a large document store to complete a RAD project. Okay, so it's more to give you experience rather than to do anything at production scale. Does that answer your question?
Yeah, I'm a NU as a student, and I don't know. I haven't used a GPU resource like provided by the school. I don't know how to access to that.
Okay, that's great. So what you can do is join this channel. Okay, it says prereq prep. Okay, anything to do with prerequisites, including compute, you can ask there. I will answer in due time. The short answer is NUS students are of two types. Okay, NUS students who have availability of compute within their faculty or general NUS. Okay, like the HPC cluster, as well as SOC students. SOC students, we have our own compute. It's not quite as nice as the Hopper HPC that's coming up for all NUS-wide projects, but NUS SOC students already have compute available to them. If you're an NUS SOC student and you don't know how to use the compute, again, join the prereq prep channel, this one over here, and then we will try to guide you along. Okay. If you happen to be in an external agency or company and you have availability of compute, you can also advertise, okay, to students who are taking this class. Hey, look, I'm from XYZ company or XYZ agency. I can make some compute available. We can manufacture accounts so that you use our GPUs because you're part of this course, and I trust that you're doing it for the right thing. Not, for example, Bitcoin mining on our system. Okay, so that's a common complaint that we have, that GPU resources and CPUs are being used to make money instead of doing research. Does that answer your question, sir?
Yes, thank you.
Okay, so you can go ahead and ask a question on that, and you can come back and answer. So I think if I'm not wrong, one of our students already wrote. So Yisong, who's there in the black over there, he's always very helpful in scribing information. So he's already written that down. Okay. All right. Let me go back to the slides for a minute. Okay. So what we have here are a couple of resources. We've used the short linker, which belongs to SOC, soc-n.us. Okay. And we've created a set of short links. So if you tag soc-nus CS6101 -T2510, which is our current semester, and then you add --Slack, you will get to our Slack workspace. You add --Drive, you will get to our Drive. You add --Sheet, you will go to the sheet that I just showed you, but it's already pinned in the Slack chat. Right? Zoom is where we'll keep the lecture simulcast, so you already have the bit.ly link. It goes there as well. YouTube goes to the archive playlist. The website goes to the website where you have to make pull requests to change and update the website to keep information about the lectures that you're giving. And the paper repo, which contains a list of useful papers, we will also, as a class, help to scaffold and build. Okay, so you need to do a pull request to that. I'm assuming everyone here is at least computing savvy enough to know how to issue a GitHub pull request. Okay, because the website and the paper repo are basically static web pages or markdown files. Okay, so then you need to modify those in order to get those resources up to date. Okay, and we have a short linker. We have an account just for our class. You guys will be manufacturing links to that using the same setup so that we can keep everything canonicalized. All right. Everyone happy with that so far? I'm going to just double check the chat. Okay, Yisong put general bookmark sheet. That's a couple minutes ago. So that's all good. Okay. So again, what does lecture mean? Lecturing means leading the discussion. It's out of the way for those of you here. And preparing a slide deck to present from. Okay. And again, the lectures are supposed to be pretty short, about 20 minutes, only 3 or 4 people. So that means roughly an hour or so. What do we do with the remaining time? We discuss. Okay, it's not meant to be just presenting papers. Okay, we can do that again. There are plenty of very good tutorials in which I will copy from for today's lecture. Okay. So support actually means all the things that are separate from that, and I will cover them now. So importantly, I booked this classroom so that those of you in the classroom can use the stylus and the touchscreen here to make annotations. All of us are familiar with Zoom, right? So you know how to make annotations in Zoom, right? So there's this annoying bar that you have to press for annotate, and you can draw things on the screen. You can handwrite, read things. You have to be comfortable with that. And because we're using Google Slides for our slide deck, that means you need to know Google shortcuts as well, right? So arrow key, A to get to the arrow key, L for laser, right? So you can use the laser pointer. And then to jump to a particular slide, you need to know how to do that, right? Press the slide number, then return, then you go to the slide, okay? So these are things that even your lecturers fumble a lot during lectures, right? You'll see people like, oh, you asked a question, but that was 30 minutes ago. Now they go one by one through all the slides, right? So that can be very taxing. If you practice more, then you can do better at it because you can jump to the slide directly. Okay. All right. So what we are going to do for lecture is very simple. Okay. So what we're going to do is basically assign one person to lead the coordination of the lecture. Okay. Their purpose is basically to introduce the lecture and also to take one segment of the lecture. One segment of the lecture, as I said, is about 20 minutes long. It can cover 1 to 3 papers, depending on what information you want to cover. Okay. The important thing is not all of the technical details, and it is specifically not all of the the results. Okay, many results from papers, they're very scripted, conventional, and boring. Okay, they basically say you introduce this method, this beats all of the previous baselines, so publish me please. Okay, and that's the recipe. Okay, but we actually don't care about the results. We want to know why the things work. Okay, so we don't need to include result slides. Okay, we just want to know what's the idea, how does it relate to other ideas that we've heard, okay, and then we'll ask questions. Okay, so I expect all of you to be engaged, ask questions. I will do my best to also pepper you with questions, but again, this is not a confrontational class. I'm not grading it. I'm asking these out of general interest, and if you don't know the answer, just say, I don't know. It's okay, right? Because we're in a reading group. Okay, it's meant to be something online where we're trying to learn how to do this process, and you can also relate to your, let's say, projects. Oh, I tried this in a project, it really doesn't work. The authors claim this, but I tried it, some replicating. Okay, that's fine, right? Okay, so what you'll need to do is, okay, today is Thursday, right? So 3 days before class, you have to meet with your team online, some form. I'll tell you about that in a minute. Decide on some core papers for each section that you want to cover. Okay, I mean, at the worst case, we'll be covering like 12 papers in one session. But that's really the worst case. The best case is you only cover 4. Okay, 1 paper per section for 3 or 4 people. Okay, because then we can discuss. All right. Because if you present too much material, again, there's no time to interact. Okay. So how do you do this? Okay, let's go back to our Slack channel. Based on the marks. Okay, you will see that there are a number of channels. So you have to go to the channel browser, right? It's here. Right? Browse channels or something like that, right? Okay, go to browse channel. And once I have declared which section you are in charge of, okay, remember those blue columns on the worksheet, right? The ones that are on the right here, okay? Once I've decided what order you're in and which lecture you're in charge of, you will have to consult here, okay? And check, oh, I was asked to do lecture 2 for you, okay? Then what you can do, okay, is go to the O2 prep channel, okay, and add yourself. Okay, these are public channels, by the way, so you can add yourself to all of them if you want to get all the traffic. Okay, doesn't matter. Okay, so the whole point is you join the channels that you are in charge or participating in, and you use that as sort of like a semi-private channel to coordinate the activities. Okay, so I can say, oh, can somebody else be the coordinator? This week's not so great for me, but I'll present the paper. Can I present in the last half? Because in the first half, I have another group meeting, I can't make it. Okay, and then I will negotiate that. Okay, it's important on the channel to declare what type of student you are, right? Like if you're a remote student or a participant, please tell the rest of the group that. Okay. So we'll use this to coordinate. I will also put some reminder messages in these channels to let you know, okay, it's Monday. I hope you guys have decided which papers you are going to present. Okay, so you need to work on that. Okay. The other thing that you'll notice is there are a number of role channels here. Okay, so those role channels you can join right now. Okay, these are channels meant to help aid people who are related in some fashion. So, for example, role general public means people who are not NUS students that are taking the course just for fun. Okay, that may want to obligate themselves to take the 70-hour commitment to do the course. Okay, so again, it says here for members of this course not affiliated with an IHL nor a student. This is a role channel used to coordinate among members of a similar role. Okay, so you join these channels to give like water cooler banter as well. Okay, we have the random channel to hit the whole class, but I found that nobody likes to use those channels because they're worried about spamming it. Okay, so that's why I created these role channels. Okay, I will leave these channels so that you can gossip or whatever on your own. Okay, but they'll be there so that all of you can use them to talk with each other. Okay, so I find that if you have a small channel of about 5 or 6 people, people tend to work a little bit better. Okay, you can also, of course, take this chat elsewhere to Telegram, for instance. Everyone has Telegram, right? So that's one other reason. Okay, so there's one for all the people doing CP 3108A or B, one for the general public, one for people who are postgraduates like PhD students or postdocs, one for people who are physically present, one for people who are remote, one for PhD students doing their lab rotation, one for undergraduates, and one's for people who are possibly trying to join my research. Okay, so you can see there's overlapping roles. So join all the channels that you think are applicable, or create a channel that fits the role. Just give it a role. Okay. Any questions so far? Okay, I really hope we can get a bit more interaction. So if you have a question. So if you're not sure about what lecture you want yet, that's okay. You can spend some time to think about it. Okay, and then we'll try to get it done within the next couple of weeks. Okay. So I've given you more information about what the lecture should look like, right? So I wrote here, estimated time is about 5 to 10 minutes per paper. Okay, try to ask yourself how to compare and contrast different approaches, and use the pen, right? The pen shows up much better on Zoom, okay? Because lecture recordings, if they're just showing a slide for 20 minutes, it's really hard to pay attention. All right, so in lecture presentation, we are going to use Google Slides for it. I'm sure you're very familiar with it. So if you go to the Drive, which is also, in here, right? If you go back to General Channel, okay, and you go to the bookmarks, you can see the Drive one here, okay? You can also use the short link, okay? So I give you multiple places to find it. You will see several things. There'll be a slide template document, which I prepared yesterday. Okay. And then what you need to do is copy this. The coordinator for lecture will copy it and rename it to whatever they want. Okay, so it should title something like whatever week number, what's the title of the lecture, and then you can copy the rest of the stuff. Okay. And then we can use this to read the slides. Okay. So you can also see previous slides done for the same type of course that we ran 2 years ago on LLM. Those are also on YouTube. There's a web page for that. Okay. So I'll just tell you a little bit about this, right? So for the slides, there is a template, right? And then the template will have you fill in all this information. Put your portraits so that we have a recording of who did which things. If you don't want your likeness to show up, just use a generic avatar. Okay. Then you can add the short link to the material. So you click the short link, you will jump back to the lecture then. Okay. All right. So that covers pretty much all of that. So the support staff is another set of roles. Okay. So what we are doing here is make sure that the lecture is accompanied with other material that's important. Okay. One part that we need to do is create a MCQ quiz that is going to be run the following week. So have many of you used Kahoot or Mentimeter or something like that before? You've seen these types of things, right? They're basically quizzes that you take with your phone and you select an option, right? And fastest fingers gets the higher. Okay, so it's not graded, but it's a good way to recap your knowledge of what happened last week. Okay, so what we're going to do is in the support team, you will actually prepare a MCQ of about 5 to 10 questions. Okay, better to be shorter on 5 because otherwise we'll run out of time. Okay, and then you set the Kahoot properly, and we'll run it the following week. Okay, so if this is week X, let's say week 2, in the following week, in week 3, at the beginning of class, we will run Kahoot. So next week, for example, I will create a Kahoot that will recap what we are going to talk about today, okay, including the logistics, but also part of the tutorial on introduction to RAG. Okay, we'll play this, it's just for fun, okay, but it will help you remember so that you come into the lecture or week X in good shape, right? So in week 3, you're like, oh yeah, I sort of remember what week 2 happened because I covered it just now in the quiz. Okay. Now, as part of that, the person doing the Kahoot has to narrate it. So they need to stand up in front of the class and narrate. Okay, like what was Min talking about? Was the all the logistics supposed to be on a Google spreadsheet, or was it on Microsoft Excel spreadsheet, or was it on pen and paper? Pick one. Okay, the correct answer was on sheets, right? Something like that. Okay. The other thing that you will need to do is, and I would like to debate this with you in a little while, is to think about scribing or writing something as a result of lecture so that it can be helpful for other people. So one of the things that you're doing in this course is preparing slides and actually giving a video lecture. And these will be made Creative Commons 4.0, so other people can watch them and use them. Okay, but we can also try to help ourselves. Okay, so medical students and law students, when they go into a lecture, there's usually a assigned scribe. That scribe is to take notes of lecture and to disseminate them to everyone in the class. Okay, that person has the added workload, cognitive load of paying attention to lecture and scribing down what's going on in the class. But usually that's also very helpful for them to capture information. Okay, so there'll be somebody likely assigned to that role. Now, I'm not 100% convinced that this is the best thing. Okay, one of the things I want to ask you guys about is how to use other support to make learning RAG easier for people, including ourselves. Okay, so one thing everyone does now is to use ChatGPT or an AI to ask things about the lecture material in class. Every time I go to a seminar, I do the same thing. I go look at the archive paper that the person is talking about. I go read the paper, or I feed it to ChatGPT and say, summarize this paper for me. What's so important about it? Okay, and then I use that as an aid to understand. But can we use this in some way to create an artifact, okay, a written artifact like a Google Doc, okay, that can be helpful for other people to learn? Okay, so we all know AI is here. We want to use it appropriately. Why don't we use AI during the class to help us learn and create a document that can help others learn? Okay, so if that's the case, we may change the scribe role a little bit to say, use ChatGPT in some useful way to create notes for the class. I don't want to write them myself, but I want ChatGPT to write them for me. I have to learn how to do it so I can help somebody else learn. Okay, all right. Again, I want to debate this more because all of you are students, you guys are learning. So you can tell us how you use ChatGPT to help you learn subject matter. Okay. All right. So enough with that one. Okay. The other one that we need to do is update the web pages. Okay. So the web pages are basically there's a web page for the course, and you'll need to update that with links to the lecture materials, the video when it's finished processing, and fix the YouTube thumbnail when it's finished. Okay. So these are all extra duties that are going to be assigned support roles so that we can all make the lecture more productive in the end. Any questions? I hope you guys have questions. Any questions online? Okay, everyone okay? Understand? Okay. All right. So like I said, the timeline is very simple. You have to do 3 days in advance, fix the set of papers that the lecturing group is going to decide on. Okay. Then we actually have our reading group on Thursday night at this time, okay? By Tuesday next week, okay, because this is business based, then we have to clip the video, okay, and annotate it, fix the YouTube thumbnail, okay, and by weeks, 1 week later, finish whatever document that we want, okay, and then put the set of papers that we discussed into the website. Okay. So I think you've all seen the website, but I'll just show it just in case you haven't seen it. And okay, so you can see here right now it's pretty empty, right? There's no video, there's no slides. Okay, these don't work. They just go to example.com. So we have to fix that, right? So every week the support staff is assigned to this. We'll go do a PR on the GitHub. Okay, so scroll down, here's the 6101. Okay, and then edit the pages of some sort to get this done. It's not hard to do. In fact, if you have whatever odd code or cursor, you can just ask. Okay, and then just check that. I will still review the PR. If it's wrong, I'll send it back. Okay. Okay. Now the other thing that will happen, as you know, is that projects will be a large part of this course. Okay. Because it's no good if you just take lecture. You need to reinforce it with hands-on. Okay. So I think the gentleman online, I'm sorry I didn't catch your name, asked about compute. So that's a good question. You know, we'll try to make compute available for you. Okay, but it will be from the teaching arm of NUS SOC that can make compute available. All right. So you need to think over the next couple of weeks. Okay. By week 4, you need to have some idea of what you're going to do. Okay. And it's fine, you change it at the last minute. It's not okay. To do that. There'll be alternate Thursdays that you will be able to consult with project team. That means before this course is happening in the evening, that afternoon, before that, we can have consultation. Okay, let me show you what I mean by projects, because there's also a structure for that. Because if we don't have a structure, things don't work very well. Okay. So in the drive, you will see there are 5 sprints. Okay. Each sprint has a slide deck that you'll need to copy for each project group. Okay. I'm just going to show you a couple of these. Okay. So here's a ideation project slide deck, which is basically 2 slide fonts. Okay. So you need to change your project number, give your project a title. Okay. Tell us who's in your project. Okay. And tell us whether it's okay to put this on the website or not. Okay. If you don't mind, then say okay. We'll take this slide deck, put it as a PDF, and add it to the WING website for the GitHub. So I'll show you again what that looks like. If you go to past semesters projects, okay, you can see some of the projects that people did. Okay, and we asked them, you know, to like their LinkedIn and other things, so that it's easier for people to find them and know that they were working on, let's say this was recommendations. Okay, and they have to produce a project, and this is the result of like 70 hours of work among 1, 2, 4 people in class. Okay. So this is what you end up doing. Okay. So for this part, basically you make a copy and follow the instructions here. Basically, for the first ideation, which is due around week 4, you just tell us roughly what you have in mind. Okay. If you happen to have an academic paper you're keen on basing it on, just let us know. Okay, you can put a link. Okay, you have no idea, that's fine. Okay. And then you have to create a schedule like this that tells us what week it is and what you're doing. Okay. So this particular slide deck will change and morph over time. Okay, so I'll show you the next one. Okay. So in the next slide deck, you have the same slides, but there's other information, right? So after you start to do some development, you tell us, okay, where's the GitHub repo for my stuff that I'm collaborating on? Okay, how do I evaluate whether the system is doing anything well or not? Okay, can I give a data set that I'm using to test the RAG? Okay, then you can tell us, all right? So all of these things are things that you can add in. And again, this is just to scaffold your project. We find that if we don't give you these things, people tend not to do it because they're busy with so many other things, then they don't do this until the very last minute. We don't get good results at all, right? So because this is not a very well-structured course, we have to sort of artificially stick these things in, but they're not true deadlines. Even if you have a midterm, of course, you're going to take the midterm over this, right? Okay, but this is to help you get an idea. So if you're doing CS 3108A 70 hours, you will have to do a sprint roughly every week to 2 weeks. Okay, but there are 5 total. Okay, and you start in week 4, right? Okay, if you're doing it for 4 credits, okay, then you need to think of the sprints as longer paced. Okay, every 2 weeks, you finish 1 sprint. So you can review those things in the project channel, in the drive, and see what's the idea. Okay, so roughly, you first ideate with friends on the project channel, think about what you want to do. Okay, then the first sprint is get something running. Okay, use an LLM, get some document index up there, put things into the context of the LLM, get results. That's it. Okay, if you have something like a GitHub repo that does all of that for you, you fork it, you run it, that's fine. Okay, just get something running. Okay, you can't get it all running, that's okay. All right, development 2, continue on from there. Okay, the hope is that every sprint you get something more in your work. Okay, and development 4, next one is no longer development, it's analysis. Okay, so tell us what's wrong with the retrieval, what's wrong with the generation, study it, because this is what scientists do when they publish, right? They tell you, you know, it works well for these, but it doesn't work well for these. Try to analyze. Okay, and then presentation preparation is the last sprint. That's where you produce the poster, and then you have to present it. Okay, so you're wondering, hey, Min, you never said anything about presentation. Okay, so the last part of the presentation is in week 13. There is a project showcase that some people in this room have heard of called STEPS. Okay, it's something that I do for the courses that I also run. Okay, but STEPS is a good chance for you to present your project to the public. Okay, so you have to print out a poster. Hence, you know, all of these posters here, right? So these groups prepared a poster, and they actually stood in front of their poster and presented it to the general public to learn about whatever it is. Okay. Again, it doesn't have to be very detailed. The whole point is to have fun, learn a little bit, interact with people who say, oh, that's really cool. You guys did something on RAG. Can you tell me about the project? Okay, so that's the idea that these songs posters are here, right? This is his thing that he causal estimation, which he eventually did more work on. Okay, so we'll give you again a project template, poster template, which you can decide to use. Okay. All right. So do take a look at the project sprints so you're familiar with what's going on. Okay. I'm going to pause here again for any questions. Yes, sir. Your name again?
Sir?
Can you tell us your name
Oh,
again?
I'm Zaidan.
Zaidan?
Just asking because
Yes.
some of the undergraduates will start to put in more time into their project, right?
Mhm.
So does that mean that it's more difficult for us to group with like a person that's committing more time because they will be expected to put in more hours into the project?
I don't think so. You guys can allocate among yourselves how you want to work. Usually what we see is that people who have more time tend to do a bit more of the implementation and a lot more of the analysis. Okay, so I'll tell you, analysis matters a lot because development is very easy to do. Okay, but the problem is we don't know what how things work and why they don't work. That's the hard part. That requires a lot of manual. Okay. The other thing is that you learn a lot more from that. If you analyze, you go to an interviewer, right, who wants to interview you for a RAG post, you can tell them all the things that go wrong with a particular data set and why a retrieval system using, let's say, nearest neighbors fails to do the job. Okay, those things you cannot say if you just fork a repo and run it, right? Then you just say, I know this paper, it gets good results. Yeah, we talked about it. Does that help, Sarah? How about those of you online? Do you guys have any questions? I saw there's one question. Okay, let's see.
Professor, I had
Yes.
a question. Regarding the project, will it go side by side with the lectures? Like how will we also be presenting a little bit of the projects during the lectures, or this will happen on different days? Like I'm just trying to understand the timelines when we connect.
Great. I'll just repeat your question in case people didn't hear it. So the question is, how do the project consultations and projects work if I need to present? Is that correct?
Yes, so how will it kind of connect with the lectures that are being given, the timelines? How will they intersect?
Okay. They don't connect directly. And this is because the first part of lecture will be a little bit more introductory. And the second 2/3 of lectures by weeks will cover more advanced materials. Okay, so it depends on what you want to do. So you might decide, for example, going back to the worksheet. Okay, all right, just move it out of the way here. Okay, I want to do, for example, let's say I'm Jia. Okay, I want to do work on graph rag. Okay, and she might decide, okay, I'm already doing research on graph rag. I just want to count part of that. Or as an undergraduate, let's be somebody who's undergraduate like Sahej. Okay, he might pick, let's say, retrieval and re-rank. Okay, he didn't pick that, but I just pretended he did, right? Then he can also do a project on retrieval and re-ranking. Okay, because you're looking at those papers anyways, right? So the first thing I would advise you guys to do is, like, you're doing a lecture on that topic, find the useful papers, see whether you can replicate their results, or do something with what they put out. Okay, because there's a lot of times people put out GitHub code, but when you try to run it, there's so many exceptions, so many prerequisites that you need to install. You'll find that you need a container just to get everything running, because you don't want to damage your own laptop or other things like that. So you might want to decide how to do that. Okay. The other part of it is, when do you get feedback on those projects? So once you fill out the slide for each iteration, I and Prof. Yu Haitao commit to spending some time reviewing your slide deck and making comments. Okay. The most common comment that we make at the beginning of your ideation run is your scope is too big. Okay, it's hard to finish a project that's that big when you have this little time. Okay, so it's always good to make the project tiny, using a very small subset of the data set that you're planning to use. Okay, just try it out. Okay, do some analysis, because each sprint you're supposed to go all the way through. Okay, do the analysis, figure out the bugs, and then say, okay, well, we only tried it for a data set of 5 papers. Okay, actually, the huge data set has 27,000. Maybe we'll try to do it for 100 papers. Okay, something like that. Or I'm using a tiny 1B model. I really want to work for a 7B model, at least that's a moderate size. So I want to do that in next iteration. Okay. Does that answer your question, sir?
Yes, Professor. So essentially, like I chose week 3 LLM prompting, like Rishabh. So is it more like that? It's on row number 7. So essentially, it's like I'm saying that I'm willing to kind of contribute as a lecturer for that, and also maybe kind of create a project on those lines. Is like it's kind of conveying both things. Then
Yes, you can do both in the same area. You could also choose, although I wouldn't advise it unless you're doing it for more hours, to choose 2 different areas. Okay, so it's expected that if you choose, for example, week 3 LLM prompting, that you might do a project on prompting, but you can also choose to join another project. So when you go to the project channel, if you say, oh, these other people are really doing something interesting because they're looking at math problems. I mean, all this stuff about math Olympiad problems, right? So maybe I want to join their project instead, even though I'm doing lecturing on prompt. Okay.
Understood. This clears it up. Thank you, Professor.
All right. Zizen asked, are we automatically allocated to CP3208B after filling this form? So once you finish the form that was advertised in the DYOC channel, which is now, I think, called, did I rename it? No, it's still called DYOC. If you written this out, filled it out, then you can send your form here, okay? And then I will help you register. I think if you sent it into the undergraduate office, you should be fine. Okay. If you haven't done that, come speak to me after class, or you can write a message right here on the DYOC channel, and then we'll get that. Okay. We do manual registration for this as long as you have enough workload to put it in. Okay. So you can't hit your maximum workload, otherwise you have and you can't have taken CP 3108 before. Okay, so if you've taken it, you've already used up the course code, we can't let you do it again. Okay, so if you run into those problems, let me know, otherwise you should go. Okay, so send us, yeah, okay, thanks. Other questions? Anyone from remote? Yeah, go ahead, sir, in the room. Your name?
Vangmin.
Navin?
Prof, what do we write for project title and the description and deliverables?
For right now, for the project title, is that right?
Yeah.
For this form? You can just put retrieval augmented generation.
Oh.
Yeah. So this is just for the course registration. Yeah. So everyone's taking the same course, although the individual project that you will do will have a project title. You don't have to specify that for enrollment. Okay. You can just put whatever it says here. Project title retrieval augmented generation, starting whenever, like you can say starting today. Ending week 13. Okay, Thursday week 13. Brief description, you can just put some placeholder from the website. That's probably good enough. Okay. So if you want there to be something, you can just pick something from I don't know. I'll show you it. Yeah. Okay.
Thank you.
Thanks, Dominic. Other questions? Yes,
Is A and B
Your name?
considered 2 separate? Sorry, I'm Benjamin.
Benjamin.
Yeah, is A and B considered 2 separate courses? So
Yes.
let's say if I do A this time, I can still register for B in the future.
Yes, that's correct.
Okay.
So if you're planning to take B for 4 units later on, another prompt, then you can take the A version for 70 hours. And vice versa. Thanks. Okay, so alternate Thursdays, okay, before class from about 4 to 6, I will make available to meet with anyone who wants to do consultation. Okay, so you need to fill in your sprint information, okay, and then use the project channel. I'll just put up this. Okay, I can't show you now, but in the past, what people did is they introduced their project in a post. Okay, and then every time I fill in another slide deck, again, you take this template, you copy it to your own drive, you modify it, okay, then I'll put my slide deck here. And then I'll just, for example, take this slide. Right. copy it. And then just stick it in there. Okay. Okay, then I will know because you mentioned me that I need to go look at your slide deck, give questions and answers. Okay. So you can do this every time you finish a sprint. Okay. If you decide not to do that, that's fine. You know, again, this scaffolding is more for your help because we found that again, if you don't have any scaffold, people tend not to do very well. Okay, and we want you to really use this course to benefit you the most. Okay. All right. So yeah, because we have a number of project members and course people who are taking it from remote, you are also welcome to attend it on Zoom. So you can talk with your peers in your groups. You can manufacture your own Slack channel or use Telegram or whatever to coordinate. Then just let me know, you know, that you finished it and that you want to consult. Then again, you can join the consultation. I will let you know in week 4 onwards where that is. It will be in the same Slack link, same Zoom link. Okay, but you can join there and then we discuss. Okay. So next week in week 1, okay, I will be giving the introductory RAG lecture. I will cover a little bit now, so you have an idea of what RAG is, but I'm depending on you. Okay, so your job right now is to, over the next week or so, start to identify team members that you want to work with. Okay, it can be people taking the course, outside, doesn't matter. Okay, again, it says here, ideal team sizes range from 2 to 6 people. Singletons are okay, but not recommended. Okay, and it's also good if you try to reach across. So if you're all a member of NUS undergraduate, that's fine. But if you can incorporate some graduate students or, you know, external members, that's also great. Okay, because again, you increase your network much more when you work with people separate from you. It's harder, but it's fun. Okay, so now I'm going to cover the RAG introduction. This was in the ACL tutorial. Okay, but I'm going to take a 5-minute break so that we can reconvene at 7:15. Okay, it's a 7-Eleven right now in the back hall. So I'll start then. Okay, if you have any questions, just let me know. Okay. We'll take a break for about 4 minutes.
One more question. When do we need to send the lecture like preferences?
Ideally before by week 1.
I decide
So next Thursday.
by next Saturday. Okay.
Mhm.
Cause some of my mods haven't released like the schedule. So I want to see like when is the best.
Sure.
Yeah, cause I've considered the.
No problem. Yeah. Again, those are preferences. Unfortunately, I
Yeah.
can't guarantee. But because all of you come in early, you will have a better choice. The PhD students who come in week 3, they have less choice. We have forced them to do certain things. How are you guys all doing online? Do you guys have any questions? Oh, I see there are more questions. I'm sorry, I guess. Oh, no more questions.
Hi, sir. Can you hear me?
Yes.
As a PhD candidate, I need to join a project, join a group to do project.
Yeah, you have to do a project even if you're external member. Is that your question?
Oh, yeah, I know.
Other questions anyone has?
Professor, just a quick question. Since like I'm speaking like for the external participants, if you don't mind, just a quick.
Speak a little bit louder. I'm
Yeah.
sorry.
Am I clearer now? Is it better?
Yes.
So, kind of like an query, since I'm an external participant, if we like successfully complete the course or like do the projects and the course, Professor, do we get any kind of like a certificate or anything to like, that so that we could also like say that, hey, we have done the class from NUS and that we have good knowledge or some idea over RAG?
So unfortunately, this is not an official course of NUS. Like I said earlier, only people who pay fees to NUS can enjoy having some type of professional credential. That is why only our undergraduate students who are enrolled here can get course credit. As an external guest, the only thing we can do for you is help you list your name and your LinkedIn profile and other things as part of our website. So for example, on the website here, sorry, on the past projects, you see people's names and their LinkedIn. Okay, so these are people that some of our undergraduates may know that are graduating at the one. Okay,
Sure.
does that answer your question?
Thank you, Professor. Thank you.
Yeah, unfortunately, yeah, we can't give you more than that because that requires paying school fees.
Understood. Understood.
Okay, Chao Ming also asked, hi Prof, for FYP students. Is the registration type under WING.NUS? And is it the commitment level 70 hours? Yes, it is. Okay, so 70 hours. So if Chao Ming, you are a FYP under student under my group, and I think Chi Cheng is also a master student, then you only are required to be 70 hours. All right. So I'm gonna go through slides. Again, I will try to cover this with some more questions because it's more fun now. But again, I hope all of you ask questions. Okay, so this is a tutorial from a couple of very well-known NLP professors at ACL. ACL is the Association for Computational Linguistics. That is the premier society for people who do NLP and computational resource, computational linguistics. And they released a tutorial which you can find here. Okay, so I'm using their slides, and this is the same thing which I hope many of you will do, which is that you go learn the materials on your own. Some of them will already have tutorials, right? Some of them may actually have recordings. Okay, so you watch the recording and then you can pare back parts of it. Okay, and that will count as a lecture. Okay, you don't have to invent new materials. Okay, the whole point is like you take screenshots, hopefully at high resolution of papers that you want to discuss. Okay, and then you present them and we ask questions. We try to do things. Okay, fair game. All right, now on the slides that they released, which you can see here, some of you can take from here, okay, as well. You know, they have the slides, they have all these things here. And so I've basically taken their slides. Sometimes they'll relate papers. So for example, here, there's a couple papers like Mellon et al. 2023. So on my version of the slides, I have this as a JPEG, but I've actually added the reference to this on the bottom of the slide. And I want us all to get in the practice of putting a hyperlink on your actual slides to get to the actual paper. Okay, and for example, in the general channel, while we're talking during lecture, the person who's doing the support of the lecture can actually paste that link, right? So everyone in the class can benefit having somebody scribing in real time, saying, okay, here's the link, click on it, you see the archive paper, I'm discussing it on the slide. You have the thing on your laptop. Okay. All right. So if you have the slides, and I think many of you are on the channel, on the slide deck, okay, then you can come here. Click on it. Okay. You can also lecture in this mode so that you can see people's comments. So if you want to make a comment on the slide or something like that, let's access. I think this is just for, I'm going to turn it on commenter as well. Then if somebody makes a comment to the slide deck, we can see it here. Especially if you're remote and you don't have a microphone, you can comment on the slide, then we can see that. Okay. If you're in slideshow mode, of course, you can't see all of these annotations. That's a little bit hard, right? You know, if you're on this present mode of working, then you can still present it here as pretty legend. Okay. So this tutorial was created by friends of ours at UW and Princeton. So Danchi is very well-known faculty. She graduated from Stanford and went to Princeton. And Siwan is was a PhD student at UW. He's now graduated. He's now assistant prof. So both of them had PhD students helping them to create this tutorial. So their tutorial is Creative Commons. That's why we get to use it. I also sent them an email to let them know that we're using their stuff so that they can enjoy that. Okay, so what is a RAG system? Can anyone tell me roughly? Okay.
So it's like where you take a LLM and you give it not a source of knowledge using that can be like a database or a vector store, and it can use that knowledge before answering questions.
Great, sir, your name?
Yes, I'm JF.
JF.
Yeah, so like what he said, we're supplementing language model with external knowledge base so that it has a better way of giving the correct answer, and it also cuts down the hallucinations.
Okay, so there are two other things that Jill said as well, you know, cuts down on hallucinations and can use the information before generation, right? Those are two parts that we said. Okay, so very much it has to do with these two parts, right? Being able to retrieve information first and then using the language model afterwards, right? So first and foremost, it is a language model, right? So a language model, if you don't know, it's fine. You don't need to know the math. But the basic concept is that you have a number of variables that you're conditioning. So I hope some of us, most of us here, understand the notation for conditional probability, right? So this says here, these are the givens, right? So these are variables 1 through n minus 1, which in this case could be words, right? So we say, I've seen a number of words before, and I'm conditioning on them to spit out a new word. Okay, that new word is word n. So this is what I have to put in, right? So given the capital city of Ontario is, which could be like x1 is the capital is x2, etc. X minus 1 is, then I'm supposed to predict the next word, right? The next word is xn, right? Okay, xn. And you know, it might go through the entire corpus of vocabulary words and then output a probability distribution. So this is a very big distribution, you know, from word 1 to all the possible words in the vocabulary. Let's call that size B. Okay, and then he'll basically have you know, a couple words with higher probability brought to the bottom. Okay. Now, just like Wang Mei and Gerald said, it's going to also have the retrieval element, right? So the retrieval element means it takes from some type of external data store, whatever that could be. Could be a database, like Wang Mei said, but it could also be a retrieval system like Google or Bing, okay? That's retrieving documents and then using them as a way of helping to answer the question, right? So the way that that's done is you have the data store somewhere, okay? But you have to ask a query, okay? And the query is just like what we would ask, right? You type in a bunch of keywords or something like that. You get back a set of documents or some knowledge in the database, some database tuples, and then you use this to get things that are relevant to the query, and then you use them as input to the language model to get something out. Now, my question to you guys is, why might we call this a semi-parametric or non-parametric model? Yeah, JF. Okay.
So I think the parameters refer to the parameters model. So all the pre-training goes into the parameters. So if we're talking about non-parametric, it means that we're not relying on the parameters of the language model, but we're supplementing external knowledge to it.
Perfect, right? So when we say parametric, it just means it can be measured in variables, right? So parametric usually means in this instance that we're talking about some type of tuned neural network, right? So when we say semi-parametric or non-parametric means not doing that or not doing just that, right? So all this non part is referring to, you know, the data, right? Everything that we're doing outside. Okay, the LM is usually something that's considered a parametric model. It just has a bunch of variables, their floating point, it takes some weight, they're tuned by stochastic gradient descent or some type of optimization method. You get a pre-trained model out of that and can do this problem as up here to answer, you know, what is the next word after seeing x1 through xn, right? Does that make sense? All right. So, okay, transformers, as probably many of you know, are an architecture for creating image models. They are fully parametric. They're just a neural network. They have a certain structure, there are layers. Okay, and in our NLP class, as well as a lot of other classes in WING.NUS, we go through what this transformer architecture looks like, right? And they're usually trained on very simple tasks, like, you know, predict the next word, like we saw in the conditional probability on the last slide. And if you have a larger model with more parameters, that means it's more data hungry, because as more parameters, that's to set them more appropriately. That means you have to send in more data for it to be, right? Okay. So when we do retrieval for knowledge intensive tasks, you can think of a lot of different tasks as being represented. Like, again, some of the things that we can see here, right? Open domain question answering, where I can ask the question like this one, what that protects the digestive system from infection. Then I get a retrieval system to go out to the web like Bing or Google, right? Go through a text collection. This might be like, say, the general web. Okay, and then get back a bunch of passages or documents. Okay, it used to be that web engines produce URLs for documents, but nowadays what we do typically is retrieve passages. I mean sections of a document, and so they look a little bit more like this. Okay, this is before like the AI overview that Google does now, but passage retrieval was standard up until about 2020 or so. Okay, then we read these and then we can produce an answer. Okay. So there are lots of different systems to do this. So there's dense retrieval or DPR, covert, which is based on BERT, and a number of other things that you can look at. Okay. So dense retrieval, who knows what dense retrieval is about? How is it different from sparse retrieval? Anyone online? It's okay if you don't know. I'm going to explain what that's what.
Using embeddings.
Okay, Yusong knows. He says using embeddings. How many of us, by show of hands or on Zoom, how many of us know what an embedding is? Okay, pretty much everyone in the room. So I'm hoping those of you online are also know this, but if you don't, you can look it up on ChatGPT and it'll tell you, right? So an embedding is a vector. It's usually something like 100 dimensions or so, floating point numbers, that gives you a characteristic of the semantics of a word or phrase or a token, right? So it's a representation of something, okay? It's contrasted from sparse embeddings, which are very high dimensional, maybe 30 or 50,000, but they only represent a single word, okay? So what we do is we take those sparse embeddings and you can think about doing some kind of type of compression, if you will, into a much more dense space, so that a lot of words or things that are similar actually end up very close in the vector space. Okay, that's the idea. Okay, because sparse vectors, because they're so big dimensionally, everything is far away from each other. Okay, so why do we do retrieval-based LLMs? Okay, part of it is because we can't memorize all of the long-tail knowledge in their parameters. We take an example from the lecture. Okay, so here's a case where they asked GPT, what are 5 important papers written by Geoffrey Hinton? You probably know Geoffrey Hinton is the person who worked on neural net for a very long time about success. Finally, when GPUs came around, he was lauded for all the work that he did. Here are 5 important papers that are offered by him. These 2 are correct, but the system also gives 2 other results which are wrong. Okay, the deep learning book wasn't written by him, and the attention paper which introduced transformers was not written by him. But these are likely guesses because these are also very famous papers in terms of transformers and things related to what Hinton is. Okay. So the problem is because the parameterization of the neural network has a lot of information, but doesn't have everything up to date, it can give incorrect information in some ways. Okay, so we want to make sure that we can correct exactly what JF said and remove the hallucinations, right? Another problem is that things aren't always up to date. So if you look at this paper, which is symlinked at the bottom here, not symlinked hyperlink, okay, which is this reference here, okay, you will see that there are cases in which the information is incorrect, even though you get a large model. Okay, so here's the case where cat-based Saltzman's occupation still isn't very good, but if you look at an unassisted LLM, it's pretty weak at the beginning. But as things get more popular, they can find it easy. Okay, so there's also the problem with knowledge cutoff, right? So language models are trained at a particular time. So for example, GPT 3.5 was done before 2024. So it doesn't have any knowledge in its parameters that captures information that comes afterwards, right? So if you ask CEO of Twitter, as of September 2021, that CEO was Jack Dorsey. So it is correct that OpenAI trained their system to spit out these tokens to say when it was cut off, right? So it says that's what I know. Okay, but of course, when the tutorial was run in 2023, Linda Yaccarino was CEO. You ask it today, it'll correctly say that she's no longer the CEO. She stepped down earlier last month in July 25, replaced by Elon. Back the reins of X. Okay, so this is where we can supplement, right? Because the knowledge cutoff, it's very expensive to train a language model. So it's really good to be able to edit the knowledge that we have in a frozen model by supplementing it with data that comes later, right? So there are many ways to do that, okay? By just putting it in the data set. Of course, there are lots of research to try to actually edit existing language models, fiddle with their parameters to get things corrected. And that is a big area of research, even in SOC. Okay. So what we're doing instead is to say, we're just going to take the data store, we're going to build this at runtime with newer knowledge or with bespoke knowledge. For example, if you're in an enterprise, you don't want to put your data into a public language model, you want to keep it private, but you don't want to do all the work to index it and all these things into a language model, then you can simply do RAG, right? Put it in the data store, query it, get some database information or some web pages as a result, put it into the context of an LLM, okay, and then ask it to generate that. Okay. Now, another really good thing is the fact that LLM's outputs inherently, when you use a parametric model, are hard to figure out where the model is getting its information from, right? So when you say, complete this sentence, capital of Canada is blank, right? So the model will form a parametric distribution, probability distribution, not parametric, sorry, probability distribution over all the tokens. It'll output the most likely one, right? But where does that information come from? Well, I can't trace it to exactly one document, right? But using RAG, we can, right? So we can say, okay, by looking at what data store has been queried and what documents have been retrieved, then I can associate what I generate with a particular document or a particular artifact that is coming from the data store. Okay, this is used a lot, even in previous work. Let me just put that out of the way. Okay. So, for example, this early paper, which is Nakano, this is the WebGPT paper. Okay, browser assisted question answering feedback. Basically, you can see that these pieces of information, these text spans, right, when they were generated by the GPT model, it's GPT-2 or something, okay, then we can attribute it to the source document, right? So we can say, oh, it came from this document are where we get this information from. Okay, so that's a very nice feature because we can attribute it. We have less probability. Again, it's not 100% because this is probability distribution, okay, but it's much more likely that you get something that is correctly cited. Just check the chat. Chen Hao asks, may I ask what the axis on the right graph means? Okay, let's go back. Can you tell us which we were talking about?
Actually, it's not a very important question, but yeah, that graph.
Okay, thanks, Chen Hao. So this has to do with the popularity of the web source, web page, okay? And this is the accuracy of the system. So let's go to the paper, actually, it's more fun that way. Open up the paper, and I encourage you guys to do this too. This is very simple. Okay, so this is the same graph, right? So this is information that's not memorized parameters, right? So if I ask, like, what is Kathy Salzman's occupation, right? And this is not inside of the parametric model because Kathy Salzman's occupation may have changed since the model was cut off. Okay, so when you can see here, the bars here are pretty uniform when the popularity of the web page or source is not very high. Okay, so the popularity gets higher, it's much easier to retrieve because retrieval finds it, right? Meaning that if I do a web search, the answer is going to come up at the top of the search page. Okay, that is what it means by popularity on this side. Does that make sense? Yeah, go ahead.
Just to add on, does that imply that like this one you see that because the web page is more popular, it was used in training the LM or
No, this is to say when I retrieve additional information by using retrieval, I can find that information, right? Okay.
Okay, sorry, may I ask a further question?
Mhm.
How do they know where the cutoff is to choose? Yeah, how do they know where the cutoff is, like, because they can't measure accuracy live, right? Like when the user uses that.
Yeah, so how did they decide this cutoff, right? So I think this is a very useful chart to see, right? So let's try to walk it through, okay? What it's saying in this chart is that when things are already known to the language model, okay, and the probability distribution is already quite set because, for example, what is the capital of Louisiana is not time sensitive, okay? I can find it whether it's 1990, 2000, 2010, 2020. Answer remains stable and it's very popular, right? So that tells us that I don't need to go to the web to find out information, right? On the other hand, if I ask a question like this, all right, and I don't see like very popular results come up, okay, because you can see here, it's going down a bit, right? Then what I need is to double check my knowledge, right? Because I say, well, I don't have a really good answer to that question. It could be that I have the right answer, but it could also be that I have the wrong one, okay? And there, I need to use retrieval to find more information, right? Because there might be more information past my knowledge cutoff that can inform me, right? So that's where I can use this, right? So I say, my answer is not very popular. That's why the blue bars are low here. So I go to retrieval on the web currently, and I can ask this question of Bing, of Google, or Baidu, get web pages or snippets that answer it, and then try again. I generate using that knowledge source. Okay. So your question online was, how do I decide this dotted line, right? Is that your question?
Yeah, like when they generate it, they don't really know how accurate it is, I suppose.
Yeah, they don't, right? So you have to use a held out test set to decide that, right? So you have to get a large data set of questions and then try to figure out where the balance is when I'm answering questions right or wrong. And then have a measure, like it says here, of popularity, right? So this could be, for example, popularity, I think not of the web page, but more of the popularity of the answer when generated by the parametric language model. So for example, if you know perplexity, okay, if the perplexity of the answer is very low coming from the language model, that means it's very certain it's the right answer. And just go ahead and say it. Okay, the capital of Louisiana is whatever it is. Okay, I don't actually know what the capital of Louisiana is. Maybe somebody wants to chat GPT that. Okay, but then you don't need to do retrieval for that, right? Because that answers are state. Does that answer your question?
Yeah, thank you.
Yeah, that's a great question. So I hope we can get more of like that because it's much more fun to go through the paper and try to make sense and do it all online, right? It's pretty boring to watch this stuff. So other questions? Anyone else? Yeah, sir, go ahead.
How does RAG relate to LLMs that have web search to call integration?
It's very much related. So the question is, how is it related to web search integration, right? So usually when we think about a web search integration using a tool, it doesn't have a specific data store. Okay, so it can be using any tool, and that tool could be a search engine within a company, for example, or it could be a data store, but it doesn't need, right? So you could say, in some ways, a tool augmented LLM is more general than RAG, okay? Because RAG is specifically saying I'm using a data store, right? So for example, if I wanted to do a mathematical computation, a tool LLM might say, oh, I need to open a calculator or a Python notebook, run this code, get the output, and then use that to generate my answer, right? In RAG, you couldn't do that, right? RAG says, I need to look it up in the data store. You ask me a question, I'm going to either do something like this, right? Find out the cutoff and see whether I have a good answer or not. Don't have a good answer, I'm going to retrieve it from the data store. I get some information from the data store and I try to answer the question. But it may not be the right answer. That answer your question? Okay. So I think, again, it's something that we can discuss more, that a tool augmented LLM is more general than RAG. RAG is sort of like one specific instance of a tool aided LLM. Okay, but it's not the only one. Okay. Okay, yeah, I'll try to watch chat, but if I don't see your question, just raise your hand because that shows up even if I on slideshow. Okay, so we went through this. Okay. And we went through this. So like I was saying, when we have a knowledge source, like a data store, we can usually use that to trace where the answer is coming from, which is a really important part of RAG, right? So for example, here's another case, right? This is Bing at work. So when you go to Microsoft Bing and you say create an itinerary for exploring Toronto over 2 days, then it will go do a search, like tourist attractions into Toronto or whatever, because it has a API within Bing to do that, right? And then it will take that information, all the passages, pass it on to Microsoft's LLM, which is OpenAI at this point, right? So they call OpenAI's ChatGPT to take off the elements that you've done the passage retrieval for and spit out information, right? And because it knows it's hitting those particular documents to generate it, it can give you these marks, right? All these citation marks, right? Which tells us where we're getting that information. Okay, there's another reason that we haven't really covered, which is that we can use it to cover problems of private training data. And this is a really good use case for enterprise, right? Because enterprises, they don't want to put their data on the public web, right? So for example, you can type a prefix like East Strasbourg, etc. Okay, and then feed it through GPT-2. And this was a very old paper in 2012. Okay, where you can see it just spit out the rest of the address, right? And so you can see all this information. It actually gave the contact number, fax number, email addresses for somebody, right? So parametric LLMs have this weakness that you never know what's in the training, right? Even though they try to put guardrails and other things around this, you can in fact find individuals, contact information in older language models, but it's still there. It's just more appropriately guarded now. Okay, so it's harder to generate that. You sort of have to run jailbreaking processes to find information there. Okay. The final part that we sort of covered a little bit is that LLMs, as you know, are very, very expensive, hard to train. Okay, so why train an entire language model when you can get away with something for free, right? So if you already have, let's say, an index of documents that you're using in enterprise, or you have some other search, right? And then you can just reuse that, right? You can say, I'm going to say, like this gentleman said earlier, use a tool like a search engine, query the system to get back a set of documents. I take those documents, feed them as context into my LLM. Remember, it does this word completion. So I just add them as variables, x1 through xn before x minus 1 and n minus 1, right? I add them to the information that is given as context, and then I ask the LLM to spit out the remaining n token xn through whatever x plus x n plus k, right? All. Okay, and that was the last slide from the introduction. So I'm going to pause there and then ask you whether you have any questions so that we can discuss a little bit more. But this was just the first part of their tutorial. Next week, we'll go through some more parts on the tutorial as well as other things that we should add in. The questions that you guys have?
Professor, I had
Yes.
one question.
Okay.
Regarding the training of LLM where we use RAG, like for example, privacy makes a lot of sense, but are we thinking of maybe using RAGs when we create like small models or stuff, and that's where RAG might help? Is that like the last point about?
Yes. So here on this slide, I think you're asking about this slide, right, Rishabh?
Yes, Professor.
Okay. So it says here, we can reduce the training and inference costs because maybe what I want to do is train an LM to just generate text well, right? So it doesn't need to know a lot of information. Okay, it doesn't need to know world knowledge. It just needs to know how to speak in my native language, whether it be English or Chinese or Bengali or whatever.
Understood.
If I train an LLM for that, I don't need it to be this monolithic giant system, right, on the other side, right, which can do multilingual translation, can do math problems, can do everything, right? Because that type of model is not going to fit on my mobile phone, for instance, right? So maybe I can fit this one on my mobile phone, but I have a local data store, right? Like all the emails or WhatsApp messages, Telegram messages that I have on my phone, right?
Mm.
then I'm just asking the LLM to be competent at generating language, right? But all the specifics to answer the question, well, they're in the data store, right? They're on things that I have on my phone. They're not indexed in any parametric way by a language model, but I can use that to generate the output. Does that make sense?
Yes, something like federated learning or like basically learning privately for that particular user.
Yeah, I would say federated is a little bit different.
Okay.
Federated means we have many sources of data and each one has their own, right? So here it's more like personalization instead, right? So federated usually means that we send all of the data in some private manner anonymized to a central source for training.
Okay.
But here we're not doing that. We're just saying I have a local data store over here, perhaps on my phone, but I'm personalizing what responses I want because I'm giving this data store as a piece of information as context for the competent language generator to output information. Does that make sense?
Yes, Professor. And Professor, it might be a little away from the rack in case that then just we can skip the question. But just in terms of curiosity, we might need to understand the LLMs better, like interpretability or explainability to kind of make them smaller, right? Could you like maybe give your own thoughts on that? Like if you had any.
Okay, so smaller models do not necessarily mean they're more interpretable. Okay, like for example, if we go back to sparse and dense embeddings, sparse embeddings are usually much more interpretable because each dimension corresponds to a particular token. Okay, but when you densify it by doing dimensionality reduction, you're actually collapsing a lot of things together. Okay, so you get better performance because semantically related tokens are co-located. Okay, your vectors get more nice in terms of cosine similarity, if you know what that means. Okay, if you don't. Okay, but it means things are less interpretable from a mathematical perspective. Okay, so there are trade-offs in both directions. Okay, you have a smaller model that's been sort of like G-zipped into 2 billion tokens and can fit on your phone, and unexpanded it's 100B. Okay, then maybe after doing all that compression, you're losing a lot of interpretability. But if you're really using a smaller model that's of the same architecture as a larger model, then perhaps it's more interpretable because there are less parameters that you need to set. It becomes easier to figure out.
Understood.
Okay, great. So we still have time for questions. We have until 8. So if you have more questions, please ask. Yeah, go ahead.
Just wanted to get a bit more like you mentioned about the LLMs can easily leak private training data. How exactly does storing the data in data store help then? Because you can still get the individual data, right?
Okay, so that's a great question. Okay, so this means that our general language models don't need to store the private data, right? What we can do is when we want to retrieve private data, we put it into the data store. So for example, I'm a company. I want my human resource department to put all of their, annual reports or whatever, for I don't know, promotion purposes. I want to use a language model to help me with that. Okay, whether that's a good idea or not, we can debate. Okay, it doesn't matter. The point that functionally, what I want to do is use a language model that doesn't have that information, that's trained. Okay, and then use the data store to provide the private information that I can use in a customized application. Right. So the executives of company XYZ can use that, but other companies in ABC, they don't have access to that data store. You'll never be able to see that private data.
But they can still use the same functionality.
Yeah, so you could say as a provider like OpenAI or Google Gemini, I'm going to provide the service for you to create your custom chat GPT, right? Custom GPT. So you upload a set of documents, right? This is your data store, right? And I'm going to generate answers that are bespoke for you using information from the data store. Does that make sense?
Thank you.
Okay. Yeah.
Just now you mentioned using GZIP to compress a larger language model and smaller. Is that actually being done?
There are lots of people that are looking at optimization. There are lots of really interesting ways to do that. gzip is sort of a generic way of compression, so it doesn't do very well in terms of making things useful, right? Because after you gzip a model, you can't use inference on it. You can't run it, right? So you want to be able to compress the language model while still being able to run it, right?
Yeah.
So that's the difficult part. So that means compressing parts of the language model in a way that can still be using inference. So there's a lot of things like quantization that's done that can be doing that. You can prune certain parts of the network as well.
Quantization is what I know how people are compressing models.
So in case you don't know what quantization means, don't worry about it. It just means taking floating point numbers that are of very high precision and discarding a lot of that precision to make it less precise. So if you can imagine, if you take a number 1 through 10 and you just say, oh, it's 10, that's quantization, for instance. Okay, so you represent numbers that aren't very meaningful with low precision, but numbers that are very important with high precision. And then we can do quantization that way, because it's been shown that language models, even if you store all the information, it usually doesn't use much of its memory. Just like ourselves, we have a large brain, but we actually don't use a lot of it for most of the daily function.
So, Professor, is it something also similar to the concept of sparse and dense encoding, where you push the things like more into a closed manner so it becomes less understandable?
Yeah.
In
So
quantization.
definitely, when we push things into a smaller dimensionality, we do get some helpful scaling. Okay, but there are also difficulties in getting interpretability in that. So usually we gain and we lose at the same time.
Understood.
Other questions? Anyone online? You can ask in chat as well. So Yusong put a comment in the Zoom chat. You can also, for your non-time sensitive things, I invite you to also use our general channel to help put information in, because then it's easy to spot. Yes, sir. Your name?
For the graph earlier in the slides that we're discussing about, yeah, I was wondering if there was a reason why the retrieval augmented language models don't always improve performance, because in the latter half it's like lower than the unassisted RF, right? But imagine that it would have both the information of its parameters as well as the retrieved information. So why doesn't that improve performance?
That's a great question, and I don't know. So we're going to go look at the paper, right? So those of you have a chance to see. So this is figure 1. Let's see whether we can figure out where. And if you have ChatGPT open, just give it the paper and see whether it understands. It's beautiful. You guys want to share what you were able to find out so far? You can all look at the paper together, and if somebody sees an answer to this question, then it could. Surprised this paper doesn't actually reference it.
If I were to venture a wild guess,
Okay.
it might be possible that the retrieval might not you're retrieving the best or the most accurate results. Therefore, it doesn't beat the parameters.
Does that make sense? Yeah, so it does say here, you know, this adaptive system only retrieves when necessary, right? Based on some heuristically decided threshold. This basically means they tuned it against the test set, right? They looked at a test set and they said, oh, when the popularity or the logics tell us that it's not very likely, then I'm going to trust the retrieval results, right? Yeah, so it could be that the retrieval doesn't do as good a job because the answer in the parametric model, like JF said, a better answer. I mean, again, a project that you could do is replicate this graph, right? Like you could run unassisted LM like GPT-2, right? Something small, and then try, you know, indexing Wikipedia, for instance, or something small like that. Okay, or smaller. Yeah, Wikipedia is pretty big. And then try augmenting it and see whether you can get the same.
They actually covered this in the paper.
Okay, where?
If you scroll to right before section 6, I think. You
Or
see something
sections?
about non-parametric memories can mislead LMs. Yeah, right after, yeah, there, right above that. This paragraph above this one. Yeah, above it as well.
Oh.
Yeah, something like that.
Okay, so let's read it out. We conduct an in-depth analysis. We hypothesize that retrieval results may not always be correct or helpful, right? So for 10% of the questions, retrieval augmentation causes the LM to incorrectly answer a question that it could otherwise answer correctly. Right, so we found that on those questions, recall at 1, significantly lower than overall recall. So recall at 1 means just take the most popular answer, right? Okay, indicating that failed retrieval can result in performance drops. It doesn't say exactly what failed retrieval is, but it could be like what JF said. Yes?
Could you give us a little bit of insight into multimodal arching? Like, what's the input, the output modalities, common use cases, etc.
Multimodal is so wide, it's pretty hard to say. It depends on what type of modality that you're interested in. You know, there's a lot of different representations that you can get of multimodal. And usually that means that you are going to use some type of transformer architecture to take advantage of the structure in that type of domain. So for images, you might use a particular model for generating good image representations to do image retrieval, but it depends on your signal, right? So you know, multimodal could also, let's say, take a look at time series information like stock ticker information, or it could deal with you know, even time domain information coming from sensors from IoT. I don't know whether that helps you or not. So can you be more specific about your question?
I don't know, maybe common use cases for specifically image-based?
Image-based? So image, again, pretty wide. So you can use images like CT, X-ray scans and things like that to find anomalies. So then you have to build the structure and architectures to be able to differentiate healthy things from diseased things. If you're talking about natural images, usually we do image segmentation to try to recognize objects and then use that object inventory to index that information so that you can find similar images with the same types of objects, right? I mean, if you use a smartphone like Apple's environment, it can tell you, you know, who's in an image, right? So they obviously use some type of face detection algorithm to try to get information about what's in the picture, assign it some metadata about likelihood of a person occurring in the image, and use that to do their index. But it really depends on thing, because a picture is worth 1,000 words, right? So there's so many different ways that we can represent images that it depends on the use. Okay, so it's already 8:03. So I hope you enjoyed this first lecture, and I hope those of you online will continue to join us for the subsequent ones. So I hope everyone you'll come back next week and continue with our class. But you do need to, as we said earlier, fill out the sheet. Okay, do that as soon as possible. It's okay if you don't have dedicated, no matter what, you'll learn a lot. Okay. So with that, I thank you for coming, and I will see you next week, same time.